All right, this is to finish up some chapter 3 material. This, we probably don't even remember. It's probably been so long ago. But these are formulas that we used when we were not given the data. We were given these summary statistics. So we were given the X mean, the X standard deviation, the Y mean, the Y standard deviation, and the correlation. Remember, we're talking about bivariate data, so we have X variables and Y variables. So the average of the X's, the average of the Y's, the standard deviation for both, and the correlation. If you have this information, but not the actual data, you can still come up with the equation of your least squares regression line. So again, this is without the actual data, because sometimes you cannot release the data. Sometimes you can only show the summary statistics. In any case, I would write these formulas down. They are on the formula sheet, but I'm thinking you probably want to have your own formula sheet that's all organized. So here's your general formula of a least squares regression line. This formula right here will get you your y-intercept, and this formula right here will get you your slope. You'll notice that all of these pieces of information, like the r, sy, sx, those will be things that you're given. But you need to find the slope first, because you'll notice that it is in the formula for the y-intercept, as well as the x bar and the y bar. So it's literally just plugging those pieces of information into these two little equations to get your y-intercept and your slope, which will give you your final answer. Here's just some things to remember when you are reading through a problem. Sometimes they don't tell you what the x variable is and what the y variable is, but they'll give you clues. So whatever you're trying to predict, whatever you want to predict, that is your y variable. So keep that in mind when you're setting all of this stuff up, because they might give you this information in words. I don't know if you remember, there was a problem where it was like woodchucks and beetles or something, and I think they were predicting the amount of woodchucks based on the beetles. So then you had to know that X bar and SX were dealing with beetles, and Y bar and SY were dealing with woodchucks. I don't know if you remember that problem, but here's another thing that could likely come up on the AP test. It usually has, or it always has in the past, so I'm guessing there's a chance it could this year too. When you are given a computer output, ignore all of the stuff that's being X'd out. This is stuff that we would have covered in chapter 12, but now that that's cut out, we're not even going to need that. So just kind of ignore that. The top number underneath coefficient, is the y-intercept. The number below that is always the slope. Always. Same structure no matter what. Here's S, which we'll talk about in a moment. That's the standard deviation of the residuals. And then here's R squared. I'll also go over that. So if I was going to use this information and write my least squares regression line, here's my y-intercept, here's my slope. Remember that in your formula, a plus bx, the a is the y-intercept and the b is the slope. So put these two values together, and here would be your equation of your least squares regression line. Now, if you're asked for the correlation, remember the correlation is R. Here you're given R squared. Remember that in this particular case, R squared is not 60.6. Okay, some people are going to accidentally write it like that. It's a percent. I don't know if you can see that. So it's not 60.6. It's actually 0.606. And if you want R, you're going to have to take the square root of 0.606. Now remember, whenever you take the square root of something, technically it could be a positive or a negative. So what you have to check is the slope. Whatever the slope is, positive or negative, that'll be the same thing as correlation. So if you have a positive slope, you will have a positive correlation. If you have a negative slope, you're going to have a negative correlation. That does not mean they're the same value, it just means they share the same sign. So in this particular problem, the R, the correlation, is negative because the slope is negative. Let's see. S. Add this to your list of interpretations. I've already referred to that in a couple of my other videos. Add that on there. Likely they're going to give you S and you have to talk about what it means. So it's the approximate average residual size when you're using the line for prediction, the least squares regression line. The approximate average residual. So I have a residual plot here. The residual is the distance to that line. Okay, so some of the distances are not so big. This one's bigger. This one is pretty much 0. It's right on the line. Smaller, even smaller. This one's pretty small. A little bit bigger, a little bit bigger. Okay, if you were to find the approximate average length of those, that is what S is. Okay, you've never, on the AP test, you've never had to calculate S. So this formula is not really needed. The only reason I would have showed you this formula is for you to see that it is involving the residuals. So you'll likely be given S and have to talk about it. Now going back to this, here is where the S is given to you. So they might ask you what the value is and then what does it mean. Okay. I think I talked about R squared on the previous video. Let's look. Maybe I didn't. I thought I did. Oh, there it was. Here it is. R squared. Remember I said to put that on your list of interpretations. Okay, so that was on the previous video. So keep going. Influential points and outliers. So the yellow point up here would be considered an outlier because it has a large residual. The distance that it is away from the line is really big compared to these other points. So it stands out from the crowd. And it stands out from the crowd in the Y direction, in the vertical direction. Whereas an influential point, that stands out from the crowd, but more in the horizontal direction. So you see how a lot of the points are clustered here, and then that point is set apart in the X direction. It's close to the line, but that's exactly what makes it influential. It pulls the line toward it. If that point was gone, then you might argue that maybe your regression line would be, I don't know, maybe something like that or something like this. I know my drawing's not great, but that influential point is what's drawing the line toward it. Think about like an influential person. So those kinds of people draw people toward them. So think of that same thing with influential points. Oh, here's that R squared coefficient of determination again. I couldn't remember if I had already said it, but I did. But anyway, if you missed it on the last video, I would write this down on your list of interpretations again. Okay, and then this page, I don't know, you might want to pause it and write some of this stuff down on a note sheet possibly, but these are all the things we've talked about in this video. It's just kind of in a more compact place. I guess, you know, high leverage points might be phrasing that you might see on the AP test. So here's kind of a description of that. Influential points with high leverage can be tough to see in a residual plot since they pull the line toward it. So like this point right here in a residual plot would be like right there. It doesn't have a large outlier. It doesn't look crazy, but it's apart from the crowd in the X direction. And so that would be a high leverage point. Extrapolation, you might see that on the AP test. That's when you're trying to make predictions outside of the range of values that you were given. So oftentimes you could be given a picture that looks like this, and that's all you see. And you're like, yeah, that looks linear. Well, if you extrapolate into the future, okay, and let's say that you use a linear model and then you make a prediction that's like out here, okay, it follows the line. Well, that's risky because this is our current window and we don't really know what lies beyond that window. This could be like a zoomed in snapshot, right? And so what could potentially happen is maybe these things are growing, but maybe they eventually level off. It could be kind of like a logarithmic model. Maybe your prediction should be more like right here. Maybe what's really happening is it goes up and then it goes right back down. Maybe your prediction should be here. So extrapolation is risky. You shouldn't do it. Let me get this out of the way. They tend to like to ask questions about extrapolation sometimes on the AP test and have you talk about why it is risky. Let's see, I think that's it. Okay, that is it for today. Hope you have a good day.